Dr. N. Batmavati. I'm going to take the transistor introduction. So already we're familiar about the electronic devices. So transistor is nothing but that is your bipolar junction transistor. That is basically a current conductor device used for the purpose of amplifiers as well as the switches. So the transistor bipolar junction in general, the transistor can be classified as a two types. So one is your bipolar junction transistor and another one is your field effect transistor. So the bipolar junction transistor is three terminals. So the applications of the bipolar junction transistors is that is enormous, because nowadays the digital systems, all the digital equipments, whatever the equipments we are using in our day-to-day life, everything is based on only this transistors. So now we are going to discuss about what all the types of transistors are available and what all the configurations of transistors available, then how to convert your transistor into your amplifier. So this is your transistor structure. So transistor is a bidirectional device. So what do you mean by bidirectional? Means depending upon the current, we are input current we are applying to the base terminal of the transistor, then your output of the transistor that can be varied. And also your transistor has the three regions or three terminals. So the terminals are emitter, base and collector. So the emitter terminal is heavily doped region. So already we familiar about that heavily doped means that is your majority carriers. That carrier concentration is very high in your emitter terminal, and compared to your emitter terminal, your collector terminal is a lightly moderately doped region. So in this moderately doped region, so it will have a depletion region, width of the depletion region is very high compared to your emitter terminal. So this is called your collector. The collector terminal, the main purpose of the collector terminal is it will be acting as an output terminal of the transistor, and base is a third terminal of the transistor. So the base is an important part in your transistor. The base is called as a control part in your transistor, because depending upon the base current only your transistor output that can be varied, and base is a very lightly doped region. And this is your schematic symbol of your NPN transistor. So the transistor, it consists of the three terminals: emitter, base and collector. So how the emitter and collector terminals are differentiated means based on this arrow mark. So in practical, so if you want to differentiate the collector and emitter terminal, so this is your transistor symbol. So the transistor having the notch, so we have to keep the notch in front of our face. Then we have to do it in anti-clockwise rotation. So first terminal is emitter and next one is base and collector. So this is the way we need to identify the terminals of a transistor. In general, your transistors have a bipolar junction transistors that will be having two types: PNP transistor and the NPN transistor. So from the name itself, we know that if the N-type semiconductor region is placed in between the two P-type semiconductors, then it is said to be the PNP. And if the P-type semiconductor material is placed in between the two N-type semiconductors, then it is called NPN transistor. So out of which two types of this transistor, we prefer only the NPN transistor, because the mobility of electrons is high compared to the holes. And this is your transistor construction, and this is your emitter, base and collector region. So the purpose, actually in general, we need to give the input to this base to emitter junction, and we need to get the output from the transistor in terms of a collector current from this base to collector region. And this is your structure of the NPN transistor. So here in the base only we need to apply the input voltage through the resistor. So now it will be converted into a current, that is a base current. So now here, if suppose your input voltages increases, and by keeping our output voltage as a constant, then what would happen means your, depending upon your input voltage, your width of the depletion region, see here, this is called the width of the depletion region, it will get reduces. So the majority carriers from the emitter that will be moving towards your collector. So that will be as a collector current. So we will get the collector, that is your output current of the transistor from the collector terminal. So this is your transistor configuration. So what do you mean by transistor configuration? Means in general, if you want to find the input, if you want to connect any devices, we need the two terminals. One is from your input side and another one is from your output side. So if it is in the case of your input side, then it needs the two ports. Similarly, if it is in the output side also, we need the two ports for plus and negative, that is your positive and negative terminal of the battery. But already we know that by the construction itself, the transistor, it consists of only the three terminals. So one terminal is connected as a common for both the input and output in order to get the output from the transistor. So that is called the transistor configuration. So depending upon the terminal, which terminal we are going to taken as a common. So based on that, we are classifying the transistor as a three types. So common collector transistor configuration, common base and common emitter transistor configuration. So common collector means your collector terminal is common for both the input and output. Similarly, common base configuration means your base terminal is common for both the input and output, and your emitter is also the common emitter configuration is also the same thing. So this is your diagrammatic representation of the common collector configuration. So in this one, see to that we need to give the input current, that is through the base, and we are taking the output from the emitter terminal, and this collector terminal is a common for both the input and output section, and this is your common base configuration. So from these different types of configurations, we need to select the particular configuration according to our requirement. So the parameters to be considered for the selection of configuration is depends upon your type of your application, in which application we are using the transistor, like for the buffer circuit, or if it is in the case of the switches, or if it is in the case of your amplifiers, like your the instrumentation amplifier, in that cases also we are using this type of your configurations. So these configurations are based on in which type, in that is the selection of the configuration of a transistor is depending upon your application, particular application, and your current amplification factor, and what is an input impedance and output impedance and voltage gain, and like your regions, okay, collector current expression. So based on this parameters only, we have to select the configuration according to our requirement. So out of this three configurations, we prefer only the common emitter configuration, because the emitter configuration, it will provide your voltage gain and current gain is very high, because if it is in general, amplified gain or current gain is nothing but your ratio of the output current to the input current. So here see to that your input current is a base current and your output current is a collector current. So here always we know that your base current is, because it is a, since it is a lightly doped region, your base current is in terms of only microamps, but whereas in case of your collector current is in the range of milliamps. So the ratio of milliamps to microamps, it will provide you the good current amplification factors. So that's why we prefer only the common emitter configuration out of the three configurations. Then if suppose if it is in the case of your transistor biasing, so always we need to use that is our transistor. See to that, this is called biasing is nothing but we need to apply the external voltage. So that external voltage is always your input junction is a forward bias and output junction is a reverse bias. So that is called biasing. So if you want to use the transistor in the amplifier region, then we need to keep our biasing as a input side, we should apply the forward biasing, and output side we need to apply the reverse biasing in order to make the transistor as an amplifier. And see to that, here this is your input junction, no? So here Your N type of the material is connected with your negative terminal of the battery, and P type is connected to your positive terminal of the battery. So that's why it is called your forward biasing. Similarly, here we are applying the reverse biasing. So this is a biasing configuration we need to apply for the transistor, and this is your input characteristics of your common emitter configuration. So in general, if you want to find the input characteristics of the transistor, then your transistor output voltage, by keeping our transistor output voltage as a constant and varying your input voltage across your base to emitter terminal, and find out the input current from the base terminal of your transistor in order to find the input characteristics of the common emitter configuration. So that input characteristics procedure is a common for all the three types of a configuration. And also in general, your input characteristics of a transistor is similar to your PN diode in forward bias characteristics, because in that input characteristics we have to keep our output voltage as a constant, that is in a reverse bias mode, and in your input is in a forward bias, input junction is in a forward bias. So if it is in the input junction is a forward bias, then if you are varying the voltage across your input, then automatically your current will be varied, then it will be acting as a forward biased PN diode. So the graph, it will represent the forward biased PN diode, and this is your output characteristics of your common emitter configuration. So here your output characteristics that will be having a three regions. So this is called your active region, and this is your this is active region, and this is saturation region, and this is your cutoff region. So in your saturation region, both the input and output junctions are forward bias, and if it is in the case of cutoff region, your input and output junctions are reverse bias, and if it is in the case of the active region only, your input region is a forward bias and output region is a reverse bias we are using in it. So the active region, in the active region of your the transistor only, it will be acting as an amplifier. So we are using the transistor as an amplifier in the active region. Thank you.